Hello, thank you for watching this video. So in this video, we're doing question 7 of May, June 2022, question paper mathematics paper 2. And the topic is trigonometric functions, right? So they're saying, in the diagram below, the graphs of f and g are drawn for interval from x equal to minus 90 degrees to 240 degrees. A and B are y-intercepts of f and g respectively. No problem. They went on to say that maybe let me have a look. So you have f and g. So f is the purple function and g is the red function. So they're saying a and b. If a and b are y-intercepts of the function, which means they lie on the y-axis, as you can see over here, right? Yeah, that's about it. So at 7.1, they want us to find the length of AB. So they want us to find the length between these y-intercepts. So these points are directly above each other. So we're looking for the vertical distance, right? So to find the vertical distance, you say the big Y value minus the small y value. So in this case, you want the vertical distance. You want the vertical distance AB, right? So in that case, the big Y value will be the Y value of A minus the Y value of B. So what you need to go and find, you need to find that Y value there and the Y value there. So you have that your f of x is equal to negative half or maybe positive half of cos x. That's what your f of x is. F of x is equal to a positive half of cos x. But you know the y value there is 0, right? So if you want to find f at 0, it's going to be half of cos x, which is 0. So in that case, this is equal to 1 over 2, which is your y value here is 1 over 2 at point A. Now do the same thing, but for B. You get that your g of x is equal to what? Your g of x is equal to your g of x is equal to sine 0 minus 30 degrees. Or it's equal to sine of x if you take a minus 30 degrees, right? So g at 0 is equal to sine of 0 minus 30 degrees. If you punch that, you get that this is minus half. So which means the y value here is equal to minus half. So from this to that, it's 1 unit apart. So in that case, your vertical distance will be the big y value, which is half, minus the small y value, which is minus negative half. If you punch that, you find that your vertical distance is equal to 1, which is the distance AB is equal to 1. We're done with 7.1. We're going to go to 7.2. So what are they saying in 7.2? At 7.2, they're saying, write down the range of 3 times f of x plus 2. So they want us to find the range of 3 times f of x plus 2. No problem. What is f of x? F of x is this function over here. So f of x is equal to half the cosine of x, right? So you know that your range of f of x are the y values that your function uses, right? So you can see that it oscillates or rotates between minus a half and a positive half. So its range here is from minus half, which is minus half, to there. So here's your range of your purple function. And the range of your right function will be from minus 1 to 1, because you can see that it uses all the y values that are between minus 1 and 1 for the red one. But for the purple one, it's for minus half to a positive half. So if you want the range of this, of f of x, should be less or equal to 1 or 1 over 2, but greater or equal to negative half. Right? So those are the values that, the y values that this function takes. But if you want to create that, first multiply by 3. So if you multiply this by 3, what will you get? You get 3 f of x. So you have to multiply it throughout, because you multiply this f, so you must multiply the entire thing. So this side you have minus 3 over 2. This side you have 3 over 2, right? And then now, so you only have this part. To get the other part, you must add 2 here. So which means you must add 2 on this one, which you have 3f of x plus 2. which means whatever that you do here, you must do it both sides, which is you have 3 over 2 plus 2, and you have minus 3 over 2 plus 2, right? So in that case, this looks like it's going to be 1 over 2 less or equal to 3 times f of x plus 2. And if you're looking at this one, it looks like it's going to be 7 over 2. This is your domain, your range, sorry. Therefore, you can say my y is an element of half to 7 over 2. That's what will happen. We're done with this one. Now, we're going to do 7.3. What are they saying in 7.3? Read off from the graphs the value of x for which g of x minus f of x is equal to 3 over 2. So they want us to find the values of x for which g of x minus f of x is equal to 3 over 2. So we want value of x where your g of x minus your f of x is equal to 3 over 2. If you look at this triangle, your 3 over 2, you will get 3 over 2, you will get it for, look at sine, look at this, look at sine 60 degrees. Sine of 60 degrees is equal to the opposite side, which is root 3 over the hypotenuse side, which is 2, right? Or to get the same thing, think of cos of 30 degrees. The cos of 30 degrees is equal to the adjacent side, which is root 3 over 2, right? So I think that's what some sort of stuff that we need to do here. So it's either we look for our cos 30 degrees or our sine 60 degrees, right? No problem. So this is our function g, right? This right function. So on our function g, how would we get, so you can say our function g is defined by sine of x minus 30 degrees. So if we're looking at sine, which means we want to get something like 60 degrees, right? Since g, right, is this sine function over here, so we need to have 60 degrees here in order to get root 3 over 2, right? We need to have 60 degrees here to get that root 3 over 2. So if we want to have 60 degrees, that would mean our x value should be 90 degrees there, minus 30. Then in that case, we would have root 3 over 2. Then now, let's go and look f at 90 degrees. If you look f at 90 degrees, f at 90 degrees is 0, as you can see over there. So which means you have your sine of 6 degrees minus 0, because these are the points that are directly above each other. So the other one is 0 here, and the other one over there is root 3 over 2. So in that case, if you look at this, which means your g of 0, say your g at 0, or not at 0, your g at 90 degrees is equal to sine of 90 degrees minus 30 degrees. So this is sine of 60 degrees, which we have expressed to be root 3 over 2. Look now, f of 90 degrees, you can see over here, f of 90 degrees is equal to 0. So, which means your f of 90 degrees, sorry, not your f, your g of 90 degrees minus your f of 90 degrees is equal to root 3 over 2 minus 0, which is equal to root 3 over 2. Which means our x values, our x will have to be 90 degrees in order to get this difference, which is root 3 over 2. So this is where we stand at the very moment. This is where we stand at this very moment. So, which means your g at 90 minus of f of 9 is equal to root 3 over 2 at x equal to 90 degrees, because you can see that if you put 90 here and put 90 there, this will be root 3 over 2 and that will be 0. And you see that the difference between the two is equal to root 3 over 2. So you will get this at x equals 90 degrees. And I'm done with this one. So I'm going to clean the board and we're going to do the very last question of 7. So let's clean the board. Okay, so now we're doing 7.4. 7.4 read as follows. They are saying, for which values of x on the interval from x equal to minus 90 to 240 degrees will the product of f of x and g of x be positive? So they want us to find the values of x where when you multiply the y values of x and the y values of g are positive. So this, you can think of this as a product of the y values when these functions are directly above each other. So they're asking you, in which positions will this the product of these y values of these functions will be above or will be positive, right? So in order to get a positive, in order to find a positive answer, it's either you multiply both negative functions or you multiply both positive functions. Now, if you multiply negative functions, the negative terms to be positive. If you multiply the negative positive terms to be positive as well. So we want the values of x where our functions are essentially both positives or both negatives. Look here, from here to there, this one is positive, right? And this one is negative. So this the x values that are less than 0, we don't want them because one is positive and the other is negative. One where both of them are positive. Look now, from 0 to 30 degrees, you can see that the red function is negative. From 0 to 30 degrees, the purple function is positive. Right? No problem. But we don't want this because you can see here, this one is positive and the one, sorry, this one is negative, the red function, and the purple one is positive up there. We want where both of them are either positive or both of them are either negative. Now, let's look at between 30 and 60 degrees. You can see the red function is positive between the two positions from this to 90 degrees, right? And this one is positive as well, but 0 there, right? So we're going to exclude this point. We're going to exclude it. We're not going to include it because the function is 0 there. Once it's positive or negative, but after that it becomes positive. So this one is positive up here, so it's okay. But that one over there is 0. So we're not going to include this. But this one was still positive there. So your function will be positive where they are both positive, which is between 0 and 90 degrees. So I'll say our x should be an element of 30 degrees to 90 degrees. These 2 points are not included because these are endpoints. So, but look now, from here it's negative all the way, and so is the red. The red one is positive up to there. But look, between this interval, the other one is above and the other one is below. But look, between this 210 over here and 240. At 210, this one is crossing there, so I'm not going to include that. But after 210, it's negative and this one is negative as well. So both of them are negative here as well. So I'll say OR x an element of 210 to 240 degrees. 240 degrees included because here and there, they are both negative. So if you multiply both of them, these y values that are above each other, the answer will be positive. So that's how I'll do this one. So it's this interval here, which is this interval, where they're both positive and where they're both negative. But on other positions, one is either positive and the other is not positive, and vice versa. So we're done with question 7. I'm going to clean the board and we do question 8. I hope this makes sense to you, as it does to me. Thank you for watching. Cheers.